final talk today is from Alan Vowels from Hudbay. He's been with Hudbay for, I believe, close to 4 decades, so this was his biography right here. But I had to shorten it down, so I'll give you a few highlights. 1970, he graduated from Cambrian College Geological Engineering Tech program. 70 to 74, he worked from HBD doing HLEM, winky drilling and core logging in Quebec, Ontario, and BC. 1973, he worked on the first diamond discovery on Somerset Island with De Beers with Dr. Ray Davies. 76 to 79, he was co-owner of Northwest Geophysics, working exclusively for HBD. He rejoined HBD back in 1980, doing airborne surveys. 2000, he presented a paper describing the role that borehole geophysics played in the discovery of the Chisel North mine, 3 kilometers away from Lalor. 2009, he accepted the Bill Dennis Award with Kelly Gilmore on behalf of Hudbay for the discovery of Lalor. And 2014, he retired from Hudbay after 44 years, but he's in the office more now than he was when he actually was fully employed.
Well, thanks, Peter. I think I can. I made a couple of notes. I told Dennis I didn't want to write an abstract until I had been to the show, since I'm doing the closing remarks. And I think I can speak for everyone here that this has been such an excellent show, and every presenter presented really, really interesting stuff. And on emerging technologies and interpretation techniques. I had a text actually just a little while ago that said he had heard from several people that this is the best event of its kind they'd ever been to. So, and I agree with that. So before I start, I'll be mentioning some names at the end of my short presentation. But I want to give special thanks to Dennis, who's done a huge amount of work, and to Adam and the BC Geophysical Society, and also to Peter for agreeing to co-chair this session. So for the next few minutes, I'm just going to talk about a few lessons learned. I don't want to. There'll be a tiny bit of overlap. It's not going to be a long technical discussion, but also some notes on, or my recommendations, whatnot, for VMS exploration. And a lot of the attention recently has been on bigger, deeper, whatnot, but that's not going to be the focus of what I'm going to be talking about. So some of the lessons learned. I've said here grid lines may be too short to recognize deep anomalies. And then also zinc-rich deposits can be highly conductive. That's already been talked about. Craig Taylor talked about it, and I think Andrew touched on it as well. But the first thing, this is kind of interesting. And then I'm going to have some notes on historically tested anomalies that are inadequately explained, and I have some examples too. The first slide, actually, this one, it was Peter that asked me to put this up. And Bertil Sandström invited me over to Sweden a few years ago to do a presentation on how we do geophysics, to see how it compared to how they do geophysics. And this slide I used, this is actually the Lalor anomaly. This is from the first Crone survey done in 2003. And what I did was I extracted this 1 kilometer section is this same data out of a 3.5 kilometer long line over Lalor. Now, if you look at this, anybody would interpret that as just basically a flat line. And we have, at Hudson Bay alone, we've cut thousands of grids, and that's not an exaggeration, where the line length was 1,000 meters or 3,000 feet. So how often did we just not even see an anomaly? And I've heard people that have actually seen this response over Lalor and said, where's the anomaly? So it's just a simple little thing, and I learned this from Bob Fraser decades ago. You got to know what you're looking at. And it all comes down to very simply wavelength. When you're interpreting data, if you're looking for something deep, it's got to be a broad response, and also low amplitude. So I just thought I'd point that out because sometimes, and I've seen a lot of people overlook that and not even understand it. Now getting to the idea of the conductive zinc ore. This is really important. I've had a difficult time getting this across to a lot of people. It's been touched upon 2 or 3 times in the last 2 days. You see here, this is sphalerite, high-grade zinc ore, And if you had a sample of this in your hand, everybody loves showing a high-grade sample. So they always pick the piece of sphalerite that's solid blackjack. Well, we know it's not conductive. But this is all the interstitial pyrrhotite. It's all weaved all through the face. So if you're not looking at a core sample and you're not looking at a hand sample, but you're looking at an actual exposed face underground, it becomes apparently, immediately obvious that it's conductive and magnetic. And I always try to hammer this home. The targets we want are highly conductive and magnetic. This is the best example. You'll see a whole cluster of holes in this plan view. There was a bunch of off-hole anomalies, all vectoring into this red dot here. So we had, at the time, we had directional drilling capability. And so we were having trouble hitting this target, so we actually steered the hole. Rather than just wedging it and letting it go, we actually steered it right to this anomaly. And this was a directional target when we used the Crone borehole survey. And we succeeded in hitting it. And here's the result. A big in-hole response where we hit high-grade zinc ore, 10 meters of 10% plus zinc, and a time constant of 24 milliseconds. That's high-grade zinc ore, and that was our target. So contrary to popular belief, these rich zinc lenses, most of the time, are conductive and magnetic because of the pyrrhotite and the pyrite as well in it, and sometimes chalcopyrite. Now, getting on to a few notes about future VMS exploration. The Flin Flon Snow Lake camp has had somewhere in the neighborhood of 30,000 holes drilled. That's not just Hudbay. That's everybody, all the other people as well. And there's, I think, 30 and might be 31 mines found. So there's your ratio of about 1 mine for every 1,000 anomalies drilled. And I've thrown this number in here, 60%. I don't know how accurate it is, so I don't want anybody to hold me to it. Somewhere in a neighborhood of 50 to 70% of those holes tested historical HLEM, VLF, TURAM anomalies. Now, it's my opinion that if we had the technology back then that we have now, we probably would not have drilled 50 or 60 or 70% of those holes, because they would have been crappy anomalies. And as I say, it's my opinion that we want highly conductive magnetic targets. A lot of these targets were, if we go back and look at it now and review it, we say, my God, and we do current geophysics over it, we say, geez, we drilled that back then, but we didn't know better. So here's a hypothetical example. Here's a longitudinal. Now, let's go back about 50 years. Somebody drills this anomaly. It's an HLEM, or a TURAM or VLF. It's a poorly conductive anomaly, but you didn't know it was poorly conductive because it was the best instrument you had. So you drill this hole, and the next thing you're going to do if you hit a few values, you're going to drill a long strike, and you're going to drill down below it. So if this hypothetical situation says after you drilled these holes, you've cut it off, and you didn't have much of an anomaly, what we didn't have prior to the 80s was we didn't have borehole geophysics at all, never mind current borehole geophysics technology. So we would have missed any of this down here, and we may not have even drilled more holes along here to test it along strike. Now, this kind of scenario, and sometimes there weren't even additional holes, this kind of scenario, I know in our camp, has probably happened hundreds of times. So how many anomalies are there out right still close to surface, not a kilometer down, but right close to surface, that there's an ore body just lurking right beneath it? Anderson mine. I know we drilled several holes in it, shallow holes, and got just minor values, and it wasn't until they continued drilling, just with a little bit of persistence, that they actually hit ore grade material down 200 or 300 meters. They could easily have given up. A situation similar to this. So the best example I can come up with, I don't have a bunch of slides, but I'm just going to talk about it, was, as we all know, VMS Ventures discovered the Reed mine. They did some more detailed airborne survey than we had. We missed the boat on it. We thought it was culture, and it wasn't. So when they did a more detailed survey, they drilled a hole, and they were looking at mag, geochem, and the EM, obviously, and they make a discovery. So naturally, that gets everybody excited. Hudbay and VMS team up, and they start exploring in the area. So we started drilling areas where we had already been drilled before, been drilled for decades. And we drilled a DPEM anomaly, and we didn't actually explain the anomaly really well. We hit some mineralization with some copper and zinc values. So we did a borehole survey, and Matt Holden interpreted it and got some really beautiful off-hole anomalies. So we go and drill the off-hole anomaly, hit 7 meters of 7% copper. So now we're really excited. And then Brian Taylor gets involved. He reinterprets and reviews the VTEM. And he comes up with another target. We drill that. We hit another high-grade copper zone. This is right at surface and right within walking distance of this newly discovered Reed mine. So we continue to do further exploration, and unfortunately it didn't have a great dimension to it, but it did prove that there's more to be found right in that area and close to surface. And then VMS Ventures, they go and start drilling on some of their 100% owned ground, and they find the Cowan River zone. So these are, and this is recent, so I just wanted to point this out. And then another largely unknown fact is everybody knows that 777 mine, Canudo mine, Photo mine were all found around 1993-94. And then you'll hear the statement, a lot of people say, oh, geez, they haven't discovered a mine in 20 years. We've discovered a 7 or 8 million ton deposit, which if it was right near Flin Flon, it would be mined out by now. We hit this Burr nickel deposit. We hit the Harmon Fenton deposits, and around the Harmon Fenton deposits, there's at least another half a dozen zones. None of them are considered mines or economically viable right now because of where they sit. And there's no mill nearby, and it's too far to truck. We found, I've only mentioned a few here, Sugi, Grassberry, Windy, and Jazz in 98, 99. And what I always thought, I didn't know until somebody told me this afterwards, the Jazz zones, what it stands for is just another zone. That's how, we were finding them all over the place. And it was almost like, oh my God, now we found another one. Anyway, none of them are economic. Right now, today, someday they might if somebody builds a road in there. But 2001, when we were on a joint venture with Falconbridge, we discovered the Tower Zone. Now that's held by Rockcliffe. 2003, we discovered Talbot. And again, Talbot for sure, I think Craig will verify this. If it was sitting within 20 kilometers of Flin Flon, it would be mined out as well. The M2 zone in the Sugi Lake area. These are only just a few. I could name more. So, and they all either come to surface in the greenstone, or they come to surface beneath the Paleozoic cover. So my point is, let's not restrict our thinking to just seeing deeper and looking for big deposits, because there's still lots to be found in these old established camps. And just a couple of notes here. If we're going to have other elements for success. Innovation, Hudbay has, and I'm not just saying Hudbay, other companies do it too, but throughout all the decades, long before I was there too, Bob Fraser and Mo Prue, all of them, and a lot of the geologists, they tested ideas, and they didn't just theorize, they went out and tested them. That's where I say, I've been lucky, but I also did a lot of testing, and that's where I've had some luck, as I had the opportunity to have the people, the equipment, and good geology, obviously, to go out and actually test some of these theories, ground truth them, and make equipment work. Collaboration. I know there was an article in this, and Peter was referenced. He was saying, collaboration is essential. I agree, it's essential. I say there's not enough of it done. We're too many of us, and it includes me. I do the same thing now. I spend my day in the office sitting in front of my computer. We don't get out in a bullpen and talk about things and discuss. We all email. We don't even walk across our office to talk to somebody. We email them. I do it too, or I text them. So it's something maybe we should learn learn to communicate a little bit better. And enthusiasm, well, that goes without saying. But this is, I joke about it in the office. I say, this is one thing I'm going to teach some of you young people before I go, is how to promote your project. Because you can be the best geophysicist or best geologist in the world, but if you can't sell it to somebody, they're not going to drill it. So you have to have passion and enthusiasm as well as the technical know-how. And here are this is the famous Dub 33, surveyed by two infamous characters, Heine Weisberg, who unfortunately died a few weeks ago, and Jim Sparling, who is here. They surveyed it in I can't remember if it was 92 or 93 when they surveyed it. Was it 92? Yeah. Was it 93? I'm getting old now. I'm officially old. I turned 65 last week, so I got excuses for my memory. But anyway, this hole, I think it's about this big now because we've surveyed it about 150 times. Everybody's had a crack at it. Now, you've seen this slide a dozen times, and this is actually how close it was to the Lalor bullseye. And I can't honestly stand up here and say that distant anomaly is adequately explained. We still might find something there yet that's not been drilled, because there's not a lot of holes between the Lalor deposit and Dub 33. And then this is a picture that was taken. There's actually Peter Dewick is right here. I've got him standing over there taking the picture. He is actually there. And Rob Black. Coincidentally, both Peter and Rob, this was prior to even going to university, they were the two guys working for Dave Coop that actually read the instrument that did the survey that we drilled, that discovered Lalor. I was just playing around here, just putting in time in the bush. Anyway, a few acknowledgements. Bob Fraser, of course, whose contribution needs no explanation. If you don't mind, Robbie, Bob's son, if you might just stand up for a second, for people who don't know you. Okay. And maybe Jerry, if you wouldn't mind standing up too. Yeah, Jerry was how many years were you in the Snow Lake office in charge of exploration, Jerry? 20 years. That's what I thought. I just guessed. And he always championed the Chisel Basin. That's been talked a lot about. And I won't get everybody to stand up. I wanted Robbie particularly. But Craig Taylor, who was a project manager, 2007, recommended and really pushed for the drilling of the Lalor discovery hole. In fact, I think the drill was slated for another hole. He convinced them to abandon that plan and drill this anomaly instead. So, and then Chris Roney was a project manager who supported the Chisel Basin drilling, and he coordinated the DPEM surveys that Dave and I worked on. Dave Coop, of course, did the DPEM surveys, and we talk about his reputation, but more particularly his enthusiasm is pretty remarkable. Almost peed his pants yesterday. Kelly Gilmore, who was exploration manager, who approved the drilling of Dub 168, and also was one of the recipients of the Bill Dennis Award. Brian Janser, who spent many years working in the Snow Lake area and always was a big proponent of that area. Alistair Caligari, who some of you would know, but he's not here today, was supervisor of geophysics, and he was the one that gridded in Geosoft, gridded and contoured the two pink bullseyes. So that I think that helped us to target those holes better than just profiling the data. And Dan McKechnie, who's here today, is now retired, but he spent years testing new ideas and techniques with me since right from 1982. And I just want to mention something. I'll finish by mentioning Ted Baumgartner, who was exploration manager and also a big believer in Chisel Basin. What really launched and validated borehole geophysics was the discovery of the number 5 lens at Spruce Point Mine in 1983. Dan and I worked on it together, and tested it. It was the first time we ever drilled a borehole anomaly and made a discovery. And that was very early on. I don't think we owned the instrument for a year yet. And so you can imagine everybody right now just believes in it and supports it. So that, I think that led in large part to the success of Borehole with us. And I can't leave without crediting and acknowledging these are all Hudbay people. But Bill Ravenhurst and Kevin Ralph at Crone did a huge amount of work, and then that was equipment and interpretation and advice, and also Andrew Duncan with his software Maxwell, because that's what we modeled it with. Now there's 100 other names I could mention, but these are some of the key people that were involved leading up to and during the discoveries. So I think that's about wraps it up for me. So I want to thank everybody. It was just a fantastic show.
So now that Alan told everybody about the potential in the Flin Flon Snow Lake Greenstone Belt, there was a little clause in the registration that if you found anything we're going to put into production, you have to come to Hudbay. I don't know if anybody, but if anybody's had any last questions for Alan.
Could I ask everybody to take off their name tags and leave them on the desk? We're going to use them next year. Thank you very much.
Ken, it better be an easy question because I'm getting old.
All the things like the jazz and the rest of it, it sounds like each one you had a caveat, it wasn't close enough.
Well, no, some of them.
Could you design an exploration strategy, or have you already, that just says, here's the corridors next to infrastructure. We don't look anywhere outside of that, because if you assume you're looking for Lalor, you have to drink some strange Kool-Aid, right?
Yeah.
So the assumption would be you're going to find another kind of a puffed up reed, something that's maybe 2 to 3 million tons. Has that been implemented in your strategy? Because I know historically some of the copper exploration companies, well, they actually put corridors around railways and roads and said, we don't want to find anything outside that boundary.
Yeah.
It sounds very anal, but it's actually, in your case, it sounds like you have enough statistics that it might actually make sense.
Well, I think Craig could answer that a lot better than I could because, I mean, he's in charge of the budget and has to examine these and consider these kind of things. So it's not really my place to answer that question, Ken.
But you haven't been buying up land rights along all the roads.
We definitely take that into account for our targeting. Prioritizing our targets is infrastructure, where it fits the overall plan.
Tissue pin.
Oh, at the very far back? Oh, maybe she's just waving. All right, thanks, Alan.
Alan's got a question here, or comment.
Oh, yes, Alan. The spectrum data? I can't talk about that. Are you crazy?
I asked them to come. They were busy. I don't know. They looked for it, couldn't find it. I don't know. But at any rate, they finally declined. They were at one point they were going to come, but then in the end they decided not to.
Oh, so they actually were going to come, eh?
At one point they were, yeah.
Oh, I didn't know. Okay.
Yeah.
Yeah.
Pascal was going to come.
I'm sorry, I don't fully understand the question. What the potential in? Oh, the M2 zone. I'm sorry. Yeah, I didn't fully understand it. Again, it comes down the M2 zone. You obviously know where it's located. It's beneath a lake with a provincial bird sanctuary. There's no roads or infrastructure for, I don't know, I think at least 40 or 50 kilometers. So just going back to that same conversation we just had, that's one of the very serious limiting factors. As far as the grade and tonnage, I can't recall exactly what it is. I mean, there's others in the audience could speak to that better than I could. I guess my only comment that I would make is that whole area has potential. There's no question, and just part of my talk kind of supports that idea, because that's a fairly recent area in comparative terms, relative terms, like the amount of drilling done in the immediate Flin Flon area and immediate Snow Lake area. We're still exploring in those areas, and there's been tens of thousands of holes. Where in the Sugi Lake area, where the M2 zone is, there's been a handful of holes. Like it numbers, I don't know if it even numbers 100. We're talking several dozens of holes. So there's certainly untested potential there. There's no question about it.
Where's Dave Fleming? Stick your hand up. Go talk to her, will you?
Say again, Richard?
They seem to have a good commitment to management to do a borehole on every hole that's drilled. What's the take on surface work? Have you covered all of the basin with Front Belt now with surface DPEM or no?
No, absolutely not. We've covered a lot, of course, because we're doing more deep penetrating EM surveys every year. But a lot of the work that was done in the past was done at 8.3 milliseconds or 16 millisecond time base, which is essentially the same frequency as airborne surveys. And there's been a lot of targets could have been missed. So we've done a fair bit. Peters and Brian are looking after that now, and there's more planned every year. There's more planned, but there's again, certain corridors, if we want to use that term, get higher priority, but a lot of areas that still have incredible potential have not even been surveyed once with modern technology.
So there's no real incentive to do a systematic program?
Systematic? No, I wouldn't say a systematic one, no. Where we pick certain areas, and then, again, you have to sell the idea to management, and if you're a good salesman, you get your way. What's that? That's amazing. Thanks, Peter.